Do I say like hi or anything or no?
Whatever feels nice.
Okay.
She's filming you this whole time.
Okay. Good. So we looked at how changes in energy efficiency, subsidies, and the progress ratio in the transport sector impact EV adoption rates.
Okay. And we used like On-Road's an online model to sort of run different experiments, and then we used a Bass diffusion dynamics model to analyze sort of the more consumer side impacts in relation to our results.
So my group and I for Engines 19, the future of energy systems, looked at the uptake in EVs compared to internal combustion engine vehicles. And we compared two policies, subsidizing and spending policies, which invest in infrastructure and make EVs cheaper. And we looked at caps on internal combustion engine vehicles, like in California. And our resounding conclusion was that spending policies, which work on subsidies and infrastructure, dramatically increase the uptake in EVs, which is really kind of an important conclusion. We see a lot of people trying to implement caps on ICE vehicles all over the world, and they keep getting rolled back. But we're seeing that they're really just not as effective, and it's probably not worth the political capital and not worth the cost of doing so. So yeah, that was our finding. It was a great term, and we're happy to do it.
Hi, my name's Uma, and I'm taking Engines 1901, the Future of Energy Systems, with Professor Steve Peterson. Here is my group's final project, which is supplier demand comparing climate change mitigation levers across economic growth scenarios. So for this project, we use the En-ROADS model to simulate different projects that the class chose. This one was ours, and across these many graphs, maybe a few too many, we found that demand-side levers were more impactful for temperature changes, carbon emissions, and energy intensity. This was a really great class and a really great project. I didn't know anything about the energy system before I took this class, and Steve, or Professor Peterson, was such an amazing guide and mentor, and I've learned so much.
I'm working on a project on bioenergy and nuclear and its role in the global energy mix. Specifically, we look at 21 scenarios and we outline 9 scenarios here, looking at the different carbon taxes and the effects on nuclear, bioenergy, and when they're both combined together. And we see that carbon tax actually has the most prominent effect on the global energy mix, and that nuclear scales faster than bioenergy.